Today we will discuss another form of differential equation that is called linear differential equation. So let us define it first. A differential equation of the form dy upon dx plus py is equal to q, where p and q are some functions of x or constants, or dx upon dy plus p dash x is equal to q dash, where p dash and q dash are some functions of y or constants, is called a linear differential equation. For example, dy upon dx plus sin xy is equal to 10x. Here we see this is exactly in the form of dy upon dx plus py is equal to q, where p is a function of x, that is sin x, and q is another function of x, that is 10x. So as we have defined, a differential equation of the form dy upon dx plus py is equal to q, where p and q are some functions of x or constants, the differential equation is said to be a linear differential equation. The second form of differential equation is like dx upon dy plus log y into x is equal to e raised to the power y. So as we have defined another form of linear differential equation in the definition, that a differential equation of the form dx upon dy plus p dash x is equal to q dash, where p dash and q dash are some functions of y or constants. So as you see clearly, this is exactly in the same form, because dx upon dy plus log y, this is a function of y, into x is equal to e raised to the power y, which is also a function of y. So this is also a linear differential equation. Now we have to discuss how to solve a linear differential equation of the form dy upon dx plus py is equal to q. As we have already discussed in the definition of this linear differential equation form, that p and q are some functions of x or constants. So in this step 1, if the given linear differential equation is not written in this form, that means in this form, so first we rewrite the equation in the above form, and if it is already given in the sum in the standard form, so we need to skip step 1. Now step 2. In this step 2, we compare the given linear differential equation to the linear differential equation with equation number 1 and find p and q. Comparing given equation to the standard form 1, we find p and q. Then in the step 3, we find integrating factor, which is written IF in short, by formula integrating factor is equal to e raised to the power integral p dx. Then in the step 4, since the required solution to a linear differential equation of the form 1 is given by the formula y into integrating factor is equal to integral q integrating factor dx plus c. So we substitute the obtained value of integrating factor from step 3 and the value of q in this equation number 2, integrating factor and q. We substitute these values in these equations. Then after simplifying, that is after integrating this integral, finally we transpose integrating factor from left hand side to right hand side, and this is how we find a solution of a given linear differential equation of the form dy upon dx plus py is equal to q. Now let us take an example of a linear differential equation. For example, the sum is solve x bracket dy upon dx plus y bracket close is equal to 1 minus y. So as we see, this linear differential equation is not given in the standard form. So in the first step we have to bring it into the standard form. For that purpose we have to transpose this x to right hand side, because it is in standard form the coefficient of dy upon dx must be unity. So if we transpose this x to right hand side, we have dy upon dx plus y on the left hand side, and on the right hand side 1 minus y upon x, which may also be written as 1 upon x minus y upon x. Now transposing this term to left hand side, because this term contains y, so dy upon dx plus y, and we transpose this to left hand side, it becomes positive y upon x. On the right hand side 1 upon x is left. Now dy upon dx plus, taking y common out of these two terms, we have in the bracket 1 plus 1 upon x, y is equal to 1 upon x. So as we see, this equation comes in the standard form now, because the standard form is dy upon dx plus py is equal to q, where p and q are some functions of x. So this is p and this is q. So in this step, comparing with dy upon dx plus py is equal to q, we have p is equal to 1 plus 1 over x and q is equal to 1 over x. In the next step, we have to find out integrating factor by substituting the value of p in the formula. Integrating factor is equal to e raised to the power integral p dx. So we have e raised to the power integral 1 plus 1 over x dx, that is equal to e raised to the power x plus log x, because integral of 1 is x and integral of 1 upon x is log x. So we may write it as e raised to the power x into e raised to the power log x by the property of logarithm and exponential function. If e exponential function has log in the index, we have e raised to the power x into x only, because exponential function will cancel, log and log will cancel, exponential function by the rule. Only x is left, so we have x e raised to the power x. Now, putting the value of the values of integrating factor and q in the equation, y into integrating factor is equal to integral q into integrating factor into dx plus c, because the solution to a linear differential equation is given by y into integrating factor is equal to integral q into integrating factor dx plus c. So substituting the values of integrating factor and q, we have y into the integrating factor is x e raised to the power x is equal to integral, and the value of q is 1 upon x, integrating factor x e raised to the power x as it is, dx plus c. Y into x e raised to the power x, because integrating factor is x e raised to the power x, and integral q is 1 upon x into integrating factor x into e raised to the power x dx plus c. Now clearly these two x are cancelled with each other, and we have only integral e raised to the power x dx plus c. So as we know that integral of e raised to the power x is e raised to the power x, so we have e raised to the power x plus c. So no further simplification is possible on the right hand side now, which is the simplest form. So at last we have to transpose this integrating factor to right hand side to get the required solution of the linear differential equation. So transposing, we have y is equal to, and these two terms will divide both of terms, so e raised to the power x upon x e raised to the power x plus c upon x e raised to the power x. So we have e raised to the power x is cancelled by e raised to the power x, so y is equal to 1 upon x plus c upon x e raised to the power minus x, because we may write e raised to the power x in the numerator as e raised to the power minus x. So this is the required solution to the given linear differential equation. Though we may also write in another form this solution as 1 upon x, taking 1 upon x common out of it, 1 plus c e raised to the power minus x, but the solution is complete. So this is an example how to solve a linear differential equation of the form dy upon dx plus py is equal to q, where p and q are the functions of x or some constant terms.